Combination is a grouping of outcomes in which the order does not matter. To illustrate a combination, we're going to compare this in a permutation. Recall that permutation is a grouping of outcomes in which the order does matter. Observing our table here, wherein we have the same given, but notice that the combination and the permutations are different. In 4 different books, 3 taken at a time, there are only 4 combinations, while we have 24 permutations. Because ABC, ACB, BCA, BAC, CAB, and CBA, each of them is unique because order does matter. While in combinations, it is just counted as one because the order or the arrangement does not matter. A combination of n distinct objects taken r at a time is represented by this formula. It is read as combination of n taken r at a time is equal to n factorials over r factorials times quantity n minus r factorials, where n is the total number of objects and r is the number of objects selected. Let us take this given example. 13 CAT officers are in a conference room. If each one shakes hands each of the others once, how many handshakes are possible? Since this given is a combination, we're going to use this formula. And our n here is 13 because we have 13 officers. And our r is 2 because normally it takes 2 persons to shake each other's hands. So we're going to substitute this given in our formula, and this is how it looks like. Then simplify. 13 minus 2 is 11 factorials. Then expand and solve. So we can simplify this. We can cancel them. 12 divided by 2 is 6, and 6 times 13 is 78. Therefore, there are 78 handshakes possible for the 13 officers. In our given number 2, in how many ways can a committee of 5 persons be chosen from 7 women and 9 men? In here, we have 3 situations. If there is no restriction on gender, so it means this 7 women and 9 men, we're going to use them also. It means there are 16 persons. But what if there's a restriction wherein only all women will form a committee of 5 persons? And what if there's a distinct number of women, let's say 3 women and 2 men, to form a committee of 5? So how do we solve that using combination? So let's start with letter A. So in here, our n is 16 because there is no restriction on the gender. So it means we can use any of them, men or women. It doesn't matter. So 7 plus 9 is 16. So that is our n. And our r here is 5 because we want to form a committee of 5 persons at a time. So using the combination formula, then substitute the given. So n is 16. R is 5, then solve, and we will get 4,368. So it means there are 4,368 ways to form a committee of 5 with 16 persons. But what if it is restricted for all women only? So in this case, our n is 7 because we only have 7 women in 16 persons. And our r is still 5 because we want to form a committee of 5 persons at a time. So same process, using the combination formula, substitute the given. So 7 factorials, then 5 factorials for r, solve, and we will get 21. So it means there are 21 ways to form a committee of 5 persons wherein they are all women. And lastly, what if there's a distinct number of women? Let's say 3 women and 2 men to form a committee of 5 persons. So in here, we have 2 combinations and we're going to solve them separately. Let's start with 3 women. So since we have 7 women and we want to choose 3 out of 7 women, so in here, our n is 7. That's the number of women in our given. And we want to get 3 taken r at a time from our given restriction. So we're going to substitute this in our combination formula, and the combination is 35. Then, we're going to solve for the combinations of 2 men from these 9 men. So, our n here is 9 because there are 9 men in our given, taken 2 at a time. We want 2 men to form a committee of 5 persons. So using the same process, substitute in our combination formula, and we get 36. Then from here, we're going to use the fundamental counting principle. Since there are 35 combinations of women and 36 combinations of men, we will get their product, and that is 1,260. And that is the number of ways to form a committee of 5 persons wherein it is consist of 3 women and 2 men.